Okay, this is part 2 of lesson 6.2, all about parallelograms. We just went over 4 rules of parallelograms, and now we are adding 2 more. These have to do with the diagonals. So the first one here says if a quadrilateral is a parallelogram, then its diagonals bisect each other, which means they intersect at each other's midpoints. They cut each other in half, basically. So up here in this picture of a parallelogram, AC is one diagonal and DB is another diagonal. They intersect right here at point P. So P is the midpoint of DB and of AC. So AP, this guy, is the same size as PC. And for the other diagonal, DP is the same size as PB. So each diagonal gets cut in half. And then the second rule here is if a quadrilateral is a parallelogram, then each diagonal separates the parallelograms into 2 congruent triangles, right? So we've got, you can actually do this 2 different ways, but we've got this top triangle and then the bottom triangle I left in white, or you could look at it the other way and say this triangle ABC and this triangle ADC, right? But either way, when you split a parallelogram in 2 by a diagonal, you're separating it into 2 congruent triangles, right? That's what we're talking about. Okay, so we got 3 little practice problems here. We're finishing up, almost done. Find the value of each variable in the following parallelograms. So here, this side right here is 3x. This side right here is 12. This entire thing is a diagonal, so we know it's bisected here at the point of intersection. That's the halfway point. So 3x has to be the same length as 12, which means x has to be equal to 4. And then for the other diagonal, this little point of intersection here is the midpoint. So this side is 8. This side is 4y, and they're both congruent. So 8 equals 4y. Divide both sides by 4, and y equals 2. Okay, number 2. We've got 2 lines here marked congruent to each other, which is actually helpful because they wouldn't be congruent to each other otherwise. We need to know that piece of information. This diagonal gets bisected right here. So this side is congruent to this side, and this diagonal gets bisected here. So this top half is congruent to this bottom half. So this tells us that all 4 little segments or half diagonals are all the same length. So we can set 2y equal to 28 and solve for y equals 14. And we can also set 4x equal to 28. They're congruent line segments. And x is going to equal 7. So either one of those work, but we had to know that the diagonals bisect each other, that they cut each other in half. And then for this third one, number 3, we kind of have to remember rules of isosceles triangles here, and you have to know that a diagonal actually bisects an angle, a corner of a parallelogram. We haven't explicitly gone over that. We will more, but anytime you have a diagonal line going from one corner to another of a parallelogram, it's actually cutting each of those corners, each of those angles, in half, perfectly in half. So here we have this line and this line. These sides are congruent. We have this triangle here. These sides are congruent. Actually, we're going to focus on this triangle here, okay? These 2 legs are congruent, so it's isosceles, which means this angle right here is 60. Right? These 2 angles are our base angles. They're across from our congruent legs, and this guy is our vertex. So if this angle's 60, this one's 60, what would this one have to be for all 3 to add up to 180? Here, I can zoom in a little. The print is like blurry and small, hard to read. Anyways, it would have to be 60 degrees here as well, right? And then we have this diagonal, which bisects that angle, cuts it in half. So half the angle would be 30. So we're going to set 2x equal to 30. Therefore, x equals 15. Okay, same thing over here. Remember, this whole parallelogram is split into two congruent triangles. So if this angle is 60, that means this one has to be 60 because they're congruent triangles. And this diagonal, again, bisects this, so it cuts it into two 30-degree angles, one of those being marked as 4y. So 4y equals 30. Divide both sides by 4. Y equals 7.5. You could write 7.5 or 7 and 1 over 2. Okay, so those are our answers. If you have questions on any of those, let me know. Now we have two problems here that ask us about, let me back up a little bit, see if we can read this, that ask us about the location of the point of intersection of the diagonals. Find the coordinates of the intersection of the diagonals of parallelogram ABCD with the given vertices. So there's no picture here. This is it. This is all we're given, right? All we know is that ABCD is a parallelogram, right? So we have to think about what are the diagonals of that parallelogram. Well, it doesn't really matter which order we write the letters in. You could start with A here, 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 or here. It doesn't matter. But then we're going to write BCD in order. So I'm going to write A, B, C, D. Again, I could have started A anywhere, but then I had to finish with B, C, D in that order. Okay, so my diagonals are going to be between points B and D and points A and C. And remember, in parallelograms, diagonals bisect each other, which means they cut each other in half, right? What's something else that bisects a line segment? The midpoint, right? The midpoint is the exact center of a line segment. If you bisect a line segment, you're cutting it down the exact center. So basically what we're saying here is that each diagonal intersects at its midpoint. This guy is intersected at its midpoint. This guy is intersected at its midpoint. So this one location, this one point, is the midpoint for both my diagonals. So what I want to do here is use the vertices given to find the midpoint. And I only need to find it for one line, but I can double check myself to make sure it's correct with the other line. Okay, so before I do that, what's the midpoint formula again? I wrote it down. It's in this little review, right? The midpoint formula. We've gone over it before, but here it is again. The midpoint between two coordinates, xy and xy, can be found using, and all you're going to do, the midpoint is a point, so it's going to be x, comma, y, right? That's what we're going to end up with. Not a number, not a fraction, a point, the midpoint, right? So we're going to take our two endpoints, and we're going to add the x's together and divide by 2 to get our x midpoint. Basically, we're averaging it. And we're going to add our two y endpoints together and divide by 2. So we're adding, divide by 2, adding, divide by 2. Once we average the x's, that gives us our midpoint x value. And once we average the y's, that gives us our midpoint y value. Okay, so for example, find the midpoint between 2, 7, and 8, negative 5. So I add my x's together, 2 plus 8, divide by 2. 2 plus 8 is not 10. Is not 8, it's 10. And then 10 divided by 2 is 5. I'll have to fix that for you guys. Right? And then 7 plus negative 5 is really 7 minus 5, which is 2. And 2 divided by 2 is 1. So my midpoint between these two guys right here is the point 5, comma 1. If I were to graph this, which I'm not going to because I don't need to, but if I were to graph this, you would see that this midpoint falls in the exact middle of this line segment, okay? So all we're doing is adding our x's together, divide by 2, add our y's together, divide by 2. So let's do that for these. Okay, so remember my diagonals are AC and DB. Let's start with AC. The midpoint of AC is when I add my x's together and divide by 2, add my y's together, divide by 2. My x's are 3 and 3. And my y's are 6 and negative 2. All right, so 3 plus 3 is 6. 6 minus 2 is 4. And 6 divided by 2 is 3. And 4 divided by 2 is 2. So our midpoint should be at 3, 2. Now, I know that's just for AC. That's the midpoint of AC. If I wanted to check, all I have to do is real quick find the midpoint of BD, and it should be in the exact same spot. If it's not in the exact same spot, then I did something wrong, but I'm going to check it real quick. All right, so the midpoint of BD, I'm going to add my x's together, divided by 2, add my y's together, divided by 2. X's for BD are 5 and 1. Y's for BD are 8 and negative 4. 5 and 1 is 6. 8 minus 4 is 4. 6 divided by 2 is 3. 4 divided by 2 is 2. So I get the exact same thing, right? So the midpoint of both of my diagonals is 3, 2, which means that's my point of intersection. Diagonals always intersect each other at their midpoint. So I'm going to back up so we can see this paper a little better and do the other one. Same exact thing. Find the midpoint of each diagonal. First diagonal is AC. So I'm going to add my x's, negative 4, negative 1. Add my y's, and I put minus 1 because it was really plus negative 1. And plus negative 1 just turns into minus 1. And then 3 and negative 2. 3 plus negative 2 is really 3 minus 2. Negative 4 minus 1 is negative 5. 3 minus 2 is 1. So basically, that's my midpoint, right? If I wanted to change it to a decimal, I could, but that's the midpoint. Let me find the midpoint of BD and make sure they're the same. For BD, I get 2 plus negative 7. And 3 plus negative 2. 2 minus 7 is negative 5. 3 minus 2 is 1. Yeah, I get the exact same thing for both of these, right? So this is the point of intersection, the midpoint of both lines. You only had to do it once. I did it twice to check myself. Okay, lastly, we have a flow proof. Now, actually, on the worksheet I got this from, all they gave you was this guy right here. That's it. There was no picture. It said, write a flow proof of the following, and then it told you the given was parallelogram ABCD, and given parallelogram ABCD, you had to prove the triangle AED is congruent to CEB. Well, wait a second, I don't see the letter E. Where did that come from, right? And what do you mean given parallelogram ABCD? That's not a fact. Well, when they tell us that a shape is a parallelogram, that implies all of the rules that go with parallelograms, right? So I went ahead and sketched out a parallelogram, and then it says, prove that triangle AED is congruent to triangle CEB. So all that tells me is that if I go ahead and draw diagonals from here to here and here to here, where they intersect is point E, right? So triangle AEB, this bottom guy, has to be congruent to triangle CEB. AED, sorry. AED, this guy, is congruent to CEB, this top guy, like side-to-side bow tie or like hourglass, whatever you want to call that. So how am I going to prove these are congruent if this is a parallelogram, right? Well, first thing I want to do in my flow proof, and I already drew the boxes for you. That wasn't there. I drew them for you. Is write my given in my very first box. And I can back up so it's easier to read. Okay, so given that ABCD is a parallelogram. Parallelogram. Draw a little parallelogram. ABCD. And my reason for writing that is because that's what's given. Okay, based on the fact that ABCD is a parallelogram, I know that opposite sides are parallel, right? I know that opposite sides are parallel. So I'm going to say both sets of opposite sides parallel. Why can I say that? What's my reasoning? Definition of parallelogram. Definition of, and I'm going to draw a little parallelogram. A parallelogram is a four-sided figure with two sets of parallel opposite sides, right? So, based on the fact that both sets of opposite sides are parallel, what can I say next? Well, knowing that this side is parallel to this guy, and this guy is parallel to this guy, and I'm trying to prove these two triangles are congruent, I could say that this angle is congruent to this angle because they're alternate interior, right? So angle EAB is congruent to angle, this guy, BCE. And why can I say that? How do I know they're congruent? Because they're alternate interior angles. The alternate interior angle theorem, which says if lines are parallel and they're cut by a transversal, then any of the alternate interior angles are congruent. Okay? Based off the same thing, I could also say that this angle is congruent to this angle. They're just on the other side here, right? Here's one transversal, alternate interior angles. Here's another transversal, alternate interior angles. So I could say ADE, angle ADE is congruent to this guy, CBE. And again, I can say they're congruent because of the alternate interior angle theorem. I know I have parallel sides. So when they're cut by a transversal, my transversals are my diagonals, it creates congruent alternate interior angles, right? And then what's something else I could say is congruent based off of this picture? Well, I could say that these angles in here are congruent, right? But can I prove that the two triangles are congruent if all three angles are congruent? No, because all three angles of triangles can be congruent, but one triangle might be really small and one triangle might be really big, right? Like if I had this equilateral triangle and all the angles are 60 degrees, and then I had this equilateral triangle and all three angles are 60 degrees, all three angles are the same size, but obviously they're not congruent triangles. This one's way bigger. So you cannot go based off of all three angles. You can go based off of all three sides, but not the angles, okay? So what's gonna help me prove that this guy is congruent to this guy? Well, I know this line right here is opposite this line, and lines that are opposite each other in a parallelogram are congruent. That was one of my rules in part 1 of this video, right, of the part 1 video. So BC is congruent to AD. BC congruent to AD. And that theorem didn't really have like a shortcut name, but it just said in a parallelogram, opposite sides are congruent. So we'll say opposite sides of, draw a little parallelogram, are congruent. Okay, and that box is down here away from this stuff because it's not really related to it, right? So based off of this, we know this is true. Based off of this, we know these two things are true. And this is kind of true on its own. It's not based off of anything else. But based on all three of these congruency statements, which is this guy, and this guy, oh, you can't see that. Why can I say my two triangles are congruent? I've got an angle, a side, and an angle, congruent to an angle, a side, and an angle. I can say they're congruent because of angle, side, angle. So I'm going to say triangle. I'm just going to repeat my proof. My prove, AED, is congruent to triangle CEB because of angle, side, angle. I proved that two angles and the side between them are congruent. So angle, angle, side. They're not in order in this proof, but they're in order in the picture. Angle, angle, with the side between them. Angle, side, angle. Right? So there's my proof, the reasoning. Let me know if you have questions. Good luck on your homework, and send me any help that you want, and I'll be happy to get back with you.